All right. Once again, hopefully you had a chance to read over the question given at the beginning. I have my initial setup here. I have a couple of random variables here. The first one being capital N, which is the number of traffic accidents occurring on a given day in whatever town that was. Okay. They tell me that N, the number of traffic accidents, has a distribution which is Poisson. They tell me that the mean, the average, is 5, and this denotes the parameter lambda, which is the convention there for the Poisson. So lambda is 5. And they tell me that if I have an accident, the probability that an individual is uninsured who is involved is 0.25. Okay. Now the question asks, what is the probability that there are 0 people uninsured involved in the accidents that day? So we have no idea how many accidents there were that day. That's one of the things you need to keep in mind. So that's sort of the motivation as to why I have this new random variable, other random variable u. This is the number of uninsured drivers involved, right? So we want to know what's the probability that there were, on that day, there were none of the drivers, in however many accidents there were, none of those drivers were uninsured. So in terms of writing this in a mathematical way, I want to know what is the probability that u is 0. That the number of uninsured drivers is 0. There are no uninsured drivers. Now again, to think about this, I'm just going to go through actually sort of my thought process here. I'm doing it the long way first, and then another much shorter way which I came up with I'll give you at the end. So the first thing, just thinking about this logically, is that if I want the probability that there were 0 uninsured drivers involved, this is equal to the probability that there were 0 uninsured drivers involved, and the number of accidents was 1. Okay, I could put 0 uninsured drivers and n equals 0, but what would that probability be? Okay, I mean, if there are no accidents, then the probability that there are 0 uninsured would be 1. So actually, now that I think about it, I should actually need that. Yeah, I actually definitely need that. So let me write that. Yeah, I definitely need that. Plus the probability that the number of uninsured drivers is 0 and the number of accidents is 1. Okay, let me continue. Right, plus the probability that the number of uninsured drivers is 0 and the number of accidents is 2, plus blah 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 blah. Right? We have no idea how many accidents there were. So these are a bunch of and statements, and if you think about this again, context of this question, these can be quite difficult to answer. It can be difficult to answer this as written. So I'm going to use the law of total probability. Okay, so I'll write out a few of those. So therefore, from the law of total probability, this says that hence the probability that the number of uninsured drivers involved is 0 is equal to the probability that there are 0 uninsured drivers given n equals 0, right? Times the probability n is 0. Okay? Plus the probability that the number of uninsured drivers is 1, given that n equals 1, times the probability that n is 1. plus keep going. So here, I'm using, let me just be clear here, going to this next step, this is the law of total probability. So that's what I'm using here. Always want to ask yourself, why would you do this? Because these conditional probabilities are actually easier to compute. Okay, let me write this in a nice compact way. Okay, using summation notation, we have the following. Therefore, the probability that there are 0 uninsured drivers involved is equal to the sum from k equals 0 to infinity. Kind of weird, there could be an infinite number of accidents. Not really, but we don't know how many. There could be more and more and more and more. Times the probability that the number of uninsured motorists involved are 0, given that n is equal to k times the probability that n is equal to k. So this is what we're after over here. This is what we want. We need to compute this business over here. We need to compute this. And as ugly as that looks, it actually is not too bad. These are all things we can compute. Now let's just take these step by step. This one right here, the probability that the number of accidents is k. Well, that is exactly just the Poisson distribution because n is distributed with Poisson. So I should have written that down, I suppose. So from this information here, this tells me that p, let me just write it this way, the probability that n equals k is equal to e to the negative k. Lambda is 5, so e to the negative 5. 5 to the k divided by k factorial. Something to keep in mind that I'll use for the easy way is the fact that the expected value of n is equal to 5. The average is 5. The mean is 5. So not a big deal. So that takes care of this piece. That's this piece right here. Now what is this piece right here? The probability that the number of uninsured drivers involved is 0, given that the number of accidents occurring on the day is k. Let's just take this step by step. So as I do usually, I just go through the cases here. What if n is 0? So what is the probability that u equals 0 given n equals 0? Right, this should be 1. If I have no accidents, then the probability that the 0 accidents involve someone that's uninsured, no one that's uninsured, is 1. I mean, if there are no accidents, then no one is uninsured. So this is 1. And I'll write this in a clever way in a moment after I get a handle of what's going on. What's the probability that the number of uninsured is 0 given the number of accidents is 1? I have an accident. That person is not uninsured. So they're insured. What's the probability that they're insured? 0.75. Because the probability they're uninsured is 0.25. So the probability that they're insured is 0.75. Alright. What is the probability that number of uninsured, is 0 given that n is 2? So what am I saying here? I'm saying I have 2 accidents. The accidents are independent. Okay, that's important here. When it also makes sense. And of those 2 accidents, both people were not uninsured. 0 uninsured. So in other words, they're both insured. Probability insured is 0.75, which means the first guy or woman or whatever was insured. The second one was also insured. So first one's insured and the second one's insured, which means I multiply them. They're independent, which means squared. So now you can think about this one. How would I write this one as 0.75 to some power? So in other words, right here, this is 0.75 to the 0, of course. This is 0.75 to the 1. I think we can say something about the probability that there are 0 uninsured given that there are k accidents. We're pretty much there actually, right? So what I can say here is the following. Okay? Again, I mean, just as I've done in other videos, I like to lay this out to get to see a pattern, because now I can say something in general. So, dot, 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 the probability that there are 0 uninsured involved, given that there are k accidents. Following the pattern here, notice this 2 corresponds to whatever value n is taking on. This must be 0.75 to the k. And you can hopefully see this makes sense, because this is saying of the k accidents, k people were insured, because none of them were uninsured. So it gets kind of confusing, but that's what's going on. That means we can compute exactly what we want. So let me give myself some more room. So I have this. So I have everything. Let's go back to what it is we're looking for here. So therefore, what we have here for the probability that the number of uninsured motorists or drivers involved in this day is equal to, using the law of total probability, we have this, k equals 0 to infinity. This is the probability that u is equal to 0 given n equals k. I absolutely do not like running out of room. Okay, let me write that again a little more compactly. Probability that u is equal to 0 given n equals k times the probability n is k. That's what we're after. We have all the ingredients. We're just going to stick that in there. We have the Poisson distribution. We have everything. So this is equal to the sum. This is equal to the sum from k equals 0 to infinity, the probability of 0 accidents given, 0 uninsured given that they're k accidents, as we discussed before, this is 0.75 to the k. What's the probability that the number of accidents is k? Poisson. We have it right there. We just copy that. So this is e to the negative 5 times 5 to the k divided by k factorial. So our last sort of thing here to do is to compute this sum. This sum looks like a nightmare, kind of, actually. But honestly, there aren't many tools that we really come up in these situations. They usually involve geometric series. This one does not, because of the factorial. What I'm going to do is I'm going to factor out what does not involve k. So I'm going to write it this way. These both have the power k, so be aware of that. So this is equal to e, I'm factoring out what does not involve k, e to the negative 5 times the sum from k equals 0 to infinity. Now both of these terms involve power of k. Use your properties of exponents to write this as 0.75 times 5 to the k over k factorial. Now unfortunately, at this level, you need to absolutely recognize what this is. What is this? Anytime you see a sum like this, you have this raised to the k power, and over k factorial, this is e, the number e, raised to the power of whatever this number is. So this right here is exactly e raised to the 0.75 times 5. And pardon my 5, they suck, they look like s's. So that is that power. This is multiplication. E to the 0.75 times 5. Alright, so this gives me the following. E to the negative 5 times e to the 0.75 times 5, which gives me, we need to, we're multiplying two exponential expressions with the same base e, add the exponents, so this is e to the negative 5 plus 0.75 times 5, right? which ends up being e to the negative 1.25. So that's my answer. And whatever, plug in the calculator, it's like 0.286 or something. That's my answer. So this is one way to go about it. Now, actually, when I first saw this question, this is not what I did. And honestly, I'm surprised at myself because I'm usually not very clever. But what I did do for this one was something different, and it's much faster, much more efficient. So let me just go over that briefly. It won't take nearly as much time. This is using the law of total probability. And now I'm going to not use the law of total probability. So what I mean is I'm going to erase some of this. I want to keep just what I began with, except for my random variable u. So what I want to do is, if you think about what we're interested in the number of accidents that do not involve uninsured drivers. So what I want to do is I want to define a new random variable in a given day, by the way. I want to define a new random variable. I'm going to call it, I'll call my new random variable, this gets kind of annoying. You've run out of letters, right? I'm going to call my new random variable, I already use k and n, so whatever. I'm going to call it m. M is the number of traffic accidents occurring on a given day that involve uninsured drivers. So that involve uninsured drivers. So this random variable itself is kind of a mouthful, but fortunately what follows is not too bad. I claim that this is a Poisson random variable. Now, we already know how many accidents we're expected to have. On a given day, we're expected to have 5 accidents. How many of those accidents are we expected to have that involve uninsured motorists, uninsured drivers? All right, well, uninsured drivers represent a quarter of those. Or sorry, a quarter of those, right? So what are we expected, in other words, what is the expected value of m? The expected number of accidents that involve uninsured motorists, okay? Well, we're expected to have 5 accidents, and a fourth of those, aka 0.25 of those, 1/4 are uninsured. So this is a Poisson random variable with mean 5/4. With mean 5/4. So what I'm saying here is that m is Poisson with lambda equals 5/4. Lambda equals 5/4. Let's write down our distribution function and what it is we're looking for. So our distribution function, Pm of m, is equal to e to the negative 5/4 5/4 to the power m, 5/4 to the power m, divided by m factorial. What is it that we're looking for? We want the probability that there are 0, basically all of the accidents that involve uninsured motorists are 0. So we want the probability that m is 0. The number of traffic accidents on a given day that involve uninsured motorists is 0. Probability m is 0. So we want probability that m is 0. Probability m is 0. So I could write it this way. The way I've been doing it is probability that m is 0. This is equal to e to the negative 5/4. But wait a minute, I mean, we know how to convert fractions. This is e to the negative 1.25. Same answer as before. Same answer as before. Again, I was shocked at myself for being able to come up with this, but this is less confusing than using the law of total probability. So, tell me what you think. Comment below. Like, subscribe. Thank you.